In this video we're going to look at converting between binary to hexadecimal, which is fairly straightforward. If we start off with a binary number, so I'm just going to say 0, 0, 1, 1 and 1, 1, 1, 0. So we've got this binary number that we'd like to convert into hexadecimal. Now what we need to do when we're converting between binary and hexadecimal is look at each block of 4 bits as a separate hexadecimal number. So traditionally with binary we would look at this as the column headers being 1, 2, 4, 8, 16, 32, 64 and 1, 2, 8. But that's not going to work in our system to convert to hexadecimal. So instead we need to break it down into 2 component parts, and each of these works on the initial system. So we're going to say 1, 2, 4 and 8, and I'm just going to put those numbers underneath that. So we've got 0, 0, 1 and 1. We've then got these 4 digits, and again they work on the start of the table. Just going to draw a line separate here. And these are 1, 1, 1 and 0. I've just copied down from above. You'll notice all I'm doing here is just changing the column headers. What we can do now is for each of these 2 different sides is we can add up what the numbers equate to. So we've got 2 and 1 here added up. Well, this is quite straightforward. I know that 2 add 1 is 3. So this side equals 3. Now believe it or not, that is our simple conversion to a hexadecimal number. That counts as a hexadecimal number, which seems awfully easy, I know. On this side, we're going to do a similar thing. We've got 8, 4, 2 and 1, so we don't need to count the 1, so 8 add 4 is 12, add the 2 is 14. Now I've got a problem here because there was no 14 in the hexadecimal system, and I always end up messing up when I try and figure out on my hands or on my fingers what is the letter representation for 14, which is why I'd always encourage you, particularly in an exam, to jot it back out, so that I know that in hexadecimal 9 is equal to 9. And I could have done this all the way up, 0, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, but this is the bit where I get confused, so I like to start from here. So what is 10, 11, 12, 13, now I need to go up to 14 for this problem, because that's the number I got here. So 10 I know must be A, 11 must be B, 12 must be C, D, E, and there's my answer. Again, this isn't completely necessary if you want to do it on your fingers, but I promise you when you're panicking in an exam, you will slip up. So we don't actually want to call it 14, we want to call this E. With the 3, we can refer to this hexadecimal as 3E. So we can say the binary representation of 0, 0, 1, 1, 1, 1, 1, 0 equals 3E. And that is converting between binary to hexadecimal. 3E is normally, just to be extra clear, denoted next to each other, just like so.